I've got this great community of amateur photographers, and so I've been reaching out to them. But it's like reaching out to each one, explaining that we're writing a book. We want to get their help with we want to pick which pictures, and then they have to get their pictures at the right resolution and hand it off to the Dropbox. And Dave's got this big checklist, and each person, it's like, chasing a million cats, and it's great. I mean, I'm so glad. I mean, when people see the book, they will have never seen any of the pictures in it, which is my goal, right?
Right, but we're feral cats.
Yes, no, absolutely. Astronomers and mostly out at night, So
Right.
it's a funny thing to.
And some of us keep traveling continents on you.
Yeah. So Pamela's going to provide the sun gun picture, but these great, like, just really creative pictures that I'm really looking forward to sort of having together in the book. But it's just been, I can't believe how much work it's been. I've been putting in a big chunk of every day for probably the last 2 months now, just cat herding. Absolutely, just yeah, no, it's good. It's going really well.
Excellent.
Hey everyone.
Hello. I have no chats open. I should fix that.
Now's your chance to say hello. I'm going to say hello. Hello to Arnold B. Arnold Post, sorry. Astroby. I just merged those two together. Ben Appleby, Bork Lankar, Catalin Buntia, Citizen Gold, Colin Jones, Concerned Rabbit, EMAC06, Gordon Dewis, Guido Bibra, Jamie S., John Drake, John Suffill, Leonard Clark, May Vision, Michael Meyer, Mr. Tom Harbin, Nitz Graziano, Noel Ruppenthal, NTWRKD, Paranor 001, Ricardo Jose Jacob, Stephen McGinnis, Thomas Traniker, and Zap Van. Hey, everybody.
I want to know what the rabbit is concerned about.
The what?
You
the
said
concerned
there's a concerned rabbit.
Yeah.
I want to know what the concerned rabbit is concerned about.
Maybe the fantastic new book that just came out about a certain bunny living at the White House. People want to know what your shirt says.
If I have to put down my coffee, the answer is no.
That's awesome.
It was totally appreciated.
All right. Oh, Steve McGinnis. I said your name. Well, that's what happens. You say hello, and then I say your name. That's how this works. It's more like a Pavlovian response from me. I see names. I say them out loud.
It's what he does.
So do you know what the Google Doodle is today? Did you look into it?
No, I don't. I just know that it looked like there was Hitler in the stars, and I was very concerned and didn't have time to find out more.
It is the astronomer, a Mexican astronomer, Harrow, the guy who came up with the Herbig Harrow objects, who discovered those.
Oh, Herbig
Harrow objects.
Yeah.
Yeah.
Okay.
Can you explain what they are?
No.
Hold on. Race ya.
I used to know.
They're a
I
kind
don't
of
anymore.
a dark nebula. Hold on.
Newborn stars.
Right.
Oh, so you have a young star like a T-Tauri or something, and they give off jets of material, and this combination of young star, the nebulosity around it, and the jets of material is the Herbig Harrow object, and they become T-Tauri stars, if I remember correctly.
Let me just share a picture so people can see it. There you go. So you there's a picture of one beside your face.
Cheers.
There you go. All right. Well, so if anyone has no idea what it is that you have stumbled into, we're about to record a live episode of Astronomy Cast. And my intro is totally messed up.
Oh, noes.
Yeah. Okay. Weird. gonna do this anyway.
Okay.
I don't like these Google sites. I just want to. I'm gonna save my intro somewhere else. But I know Susie likes them to be able to
All in one place.
in one place.
Yeah.
All right. All right. Tell me when you're ready.
I'm ready to press record when you're ready to
Here we
press
go.
record. Okay, pressing record. Hello, Chad.
Hello, Chad. Astronomy Cast, episode 485, Docking and Refueling. It's one thing to get to space. Oops, man, don't. Let me hold on a second here. We'll start your recording again. That's where the messed up came. I now understand.
Okay.
All right.
Are you ready?
Yes. Here we go.
Pressing record. Hello, Chad.
Hello, Chad, again. This is the second time we've said hello. The first time has been destroyed and will be forgotten.
And I wasn't going to tell you that.
Astronomy Cast, episode 485, Docking and Refueling. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, Dr. Pamela Gay, the Director of Technology and Citizen Science of the Astronomical Society of the Pacific, and the Director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing, Fraser?
Good. And at the time that people are listening to this episode of Astronomy Cast, you may very well be at or near the Astronomical Society of the Pacific, right?
It's oh man, so when's this one going out? I'll be 4 days
Early
from
April
being there.
Or late?
Yeah, I'll
late,
be
Yeah.
I will be almost to the ASP. I am in the middle, I realized, of 8 weeks, 8 cities, 4 continents.
I am impressed that you've been able to find the time to be anywhere near your house and to be able to record these episodes of Astronomy Cast. And I know the people who join us on the live shows, they don't know whether they're coming or going. They don't know what time it is.
I don't know what time it is.
I know.
I have no idea.
People who never get a chance to see our episodes live are able to watch them. People who normally watch them live can't watch them. It's a mixed up, crazy world right now.
Well, thank you for playing along with me, and
No problem.
it all ends soon.
It all ends, and then you'll be back home forever.
Yes.
All right, it's
No.
one thing to get to space, but once you've made it there, what do you want to do? You probably want to dock with another spaceship, deliver cargo, refuel. And today we're going to talk about how all that happens. One of the most fascinating times of the history of sort of NASA's space missions, for me, was the Gemini, or Amy Sher title was called the Gemini, but I was called the Gemini, even though she's Canadian too. Anyway, Gemini is the way you say the constellation, right?
Yes.
Right. My dad's a Gemini. Anyway.
It's Gemini. Yeah.
So one of the great things about the Gemini missions was how they did this really incremental approach over the course of the missions, learning to stay up in space longer and learning to dock spacecraft together, which was the foundation of going on the Apollo program, because there was so much docking and flipping around capsules and stuff and landing and getting back to space and docking again. So let's talk about docking, which is, if it's like the second riskiest part of spaceflight. If getting off the ground, maybe re-entering the Earth's atmosphere are the two risky parts. Let's talk about docking.
Yeah, so this is my favorite bit of space history, because the first poor American schmo who attempted to dock didn't know orbital mechanics and failed absolutely, totally, and completely in the most spectacular of fails. And it's because it turns out the way you have to maneuver is as counterintuitive as it can possibly be.
Wow.
You see that you see that thing straight in front of you. Intuitively, pretending you know nothing, what do you think you have to do to catch up with that spacecraft in front of you?
You aim towards that thing and you fire your thrusters and have it get closer to you.
Yeah, and that totally doesn't work, which is why they failed so delightfully spectacularly. So back on June 3rd, 1965, U.S. astronaut Jim McDivitt on Gemini 4 made a go of trying to catch up to his Titan II launch vehicle's upper stage. Seemed like not too bad a thing to do, seemed like it should be easy. And the problem is, as we discussed in our last episode, when you fire your thrusters, when you increase your orbital velocity, what actually happens is you go into a higher orbit.
Right.
You don't accelerate on the orbit you're on, you switch to an entirely new orbit.
So by aiming his spaceship at the target and by firing his thrusters, he moved further away from the Earth
and slowed down.
Which is absolutely right. It is so counterintuitive, right? They're like,
yes.
You would be rising up higher. You would be seeing that Titan spacecraft, that Titan upper stage moving faster than you in orbit. And then you would, of course, now you would aim your spaceship in the direction of where the booster is now, and you would fire your thrusters again.
And just make the situation worse.
Make it worse. Okay.
So this is one of those things where you really have to drop into a lower orbit, catch up, and then perform a Holman transfer orbit to get up into the orbit you meant to be in initially, going at the same velocity as the thing you hopefully don't hit.
So how did they then figure this out later on?
They went back to Earth and they learned orbital mechanics. And I wish that it wasn't as, I mean, I sound totally sarcastic when I say that. I sound like I'm making fun of them. But no, this is what actually happened. They had to come back to Earth having failed to dock Gemini 4. They went to the notebooks. They did the math. They realized Kepler's laws. That whole equal area in equal time thing totally kicked them. And then like ran some paper and pencil simulations because it was the 60s and figured out, oh, okay, we need to like be in a lower orbit and increase our velocity to bump up and slow down and like then touch and yeah. Stomach wrong.
It's funny, right? Because when you like just think this through your brain, I mean, I think you really set the stage nicely. When you imagine how you would go about this process, when you think about how, say, when the Dragon launches on a SpaceX and it's going to launch to be able to deliver cargo to the International Space Station, it's got some certain window. You kind of imagine, right? The space station flies overhead. And then the Falcon takes off, and it's got the Dragon capsule on the front, and it pushes it into this orbit that's exactly the same as the International Space Station. And then the Dragon has some little thrusters, and it just puffs its way and catches up with, and that's the way people even describe it, right? Catches up with the space station and then docks. But that is not how it works.
And what's really cool is if you ever watch the videos, you get to see the Dragon capsule come from a much lower orbit, rise up in altitude as it catches up with the International Space Station, and then it adjusts its orbit. So they're essentially station keeping until they grab onto each other.
Right. And you used to see that with the space shuttle as well. You would always see these images of the space shuttle rising up below the International Space Station with the Earth behind it. So it's great. That's kind of counterintuitive. And so then for every maneuver that you're trying to do, you've got to go through some permutation of this, right?
And it becomes really a game of circularization at the right moment in time. This is where the whole idea of station keeping comes in. And it sounds like something totally out of Star Wars, where you have some stormtrooper standing next to a desk. But what station keeping actually means is putting yourself in a orbit so that you are maintaining equal separation with time with the object that you are interested in. So later on, like you said, the Gemini missions did things increment by increment by increment. So with the Gemini 6 and 7 missions, they weren't set up to actually dock and let the astronauts go back and forth between the two spacecraft, but they did want to station keep. And Wally Schirra did the piloting. This was back December 15th, 1965, and did that drop into a lower orbit and put yourself into an elliptical orbit such that the point where you catch up with the other spacecraft, you can then fire your engines and not catch up, but you go from that elliptical orbit that's about to hit them to circularizing your orbit or putting yourself into the exact same elliptical orbit. It depends on what orbit you're catching up to. You match orbits just at the last minute as you're about to pass each other. So it's not catching up, it's crossing orbits and then syncing your orbits. And he was able to get the Gemini spacecraft so that they were only about 30 centimeters apart, hanging out, orbiting together. And that's really impressive if you think about it. 30 centimeters is like the lower arm of most adult humans.
Right.
And that's how close these two spacecraft were orbiting.
And what's so amazing, of course, is that he had to do this all by hand. Now it's all done mostly by computers, but a lot of the early astronaut pilots, they had to do this all by hand, and they didn't have the benefit of video games that would have very easily simulated it. You know, if they had been playing Kerbal Space Program, they would have been able to change their brains so that they could you know, they knew how to make the spaceship go. I mean, man, have you ever played with, you know, when you don't use your telescope and
Yes.
you've got some image that's in the telescope and you want to bring it closer to the middle, because everything is flipped upside down, you have to think in a different way, and you learn to always, after a while, in the beginning, you're always moving the object in the wrong direction, and after a while you figure it out, and then eventually you're able to actually always do it in the right direction. And you can just imagine, for these astronauts, they just didn't get enough time to be able to really get good at it until they could come up with really good simulations. So that just makes me even more impressed that they just didn't have, you know, they couldn't play all these video games.
Sometimes when I'm prepping for the show, I learn things that I feel like I really should have known and totally didn't know. And one of those things is Buzz Aldrin did a PhD dissertation. And it just like completely escaped me that he was actually Dr. Buzz Aldrin, because you never hear him called Dr. Aldrin. But yeah, he totally did a PhD. And his doctoral thesis was titled Line of Sight Guidance Techniques for Manned Orbital Rendezvous. So what is now math that we do as part of playing Kerbal Space, what I might assign as a homework assignment in the age of computers, was Dr. Buzz Aldrin's doctoral thesis.
Now let's talk a bit about some of the other orbital maneuvers that they have to do docking. So I sort of mentioned this briefly early on. Now you talked about some of the Gemini program, but when they moved into the Apollo missions, they had a lot more of these kinds of docking and rendezvous that they had to do.
And this is in part because the configurations they needed their spacecraft in at different points in time varied. How you wanted to launch everything versus how you needed to separate to land on the moon versus how you needed to then remate your spacecraft to get back to Earth and then jettison a part of your spacecraft to finish getting back to Earth. It was this crazy circus trapeze act with no net or wires or swing, just the trapeze artists.
Yeah. And I mean, so they had to do one docking maneuver when they were at in Earth orbit. And then they
Yes.
had to do, of course, when they got to the moon, they would go into orbit around the moon. Then they would detach the lunar lander. It would go down to the surface of the moon, and then it would come back up, and then it would redock with the command module for them to come back.
Yes. And so you have at one point when it's taking off, you have your Apollo module uh is happily downwards with the big command module below. You then flip everything upside down. Um it was a lot more pieces that got lugged to the moon than what you may think about. Because when we go to the museum, we see the spidery beetle looking lander, and then we see the triangular Apollo capsule. But there was a lot more. It was that whole command module that we tend to forget about. And they had to do gymnastics around that essentially.
Yeah. Now, while the Americans were having their doctoral theses, astronauts learning and practicing to the ways to do these orbital maneuvers, the Russians didn't trust their astronauts so much to be able to actually perform these maneuvers, and they
No.
turned everything over to computers.
Yes, and what's funny is the way they started their history of doing this. It actually for them goes all the way back to 1963 with the early Vostok missions. Now there was no actual station keeping involved. It was funny to me. I don't know if it was funny to them. Probably not. So in 62 they launched Vostok 3 and 4 a couple days apart. Then in 63 they launched Vostok 5 and 6 a couple days apart, stuck them into identical orbits. And they weren't entirely identical orbits, and the idea was one would catch up to the other. That didn't actually happen. Instead, they went from about 5 kilometers apart to, over time, thousands of kilometers apart. And then we have silence on the matter for quite some time.
Right. So, like, but that idea of the Russians sort of, as I said, not letting their pilots do the docking, they just went to computers.
Right. So in 71 we had Soyuz 11, which didn't survive entirely. By which I mean it didn't survive, but it did successfully dock with the Salyut 1. So that was a good start to things. Of course, we had the Apollo Soyuz mission that came later on in the 70s, which actually proved that imperial versus metric isn't the greatest problem that one could have, because the docking technologies developed by the Russians and developed by the Americans were utterly incompatible. So they had to build a docking unit to essentially translate between Russian hull and American hull. So there was that great docking episode. But since then, docking has really been that thing that means, hey, I'm going to a space station.
Mm-hmm.
And
Yes.
and this is today's, and has been in the entirety of both our lifetimes, the primary goal of docking.
Is transfer cargo and astronauts to the International Space Station, return cargo back to Earth and astronauts.
Mm-hmm.
That is the vast majority of the orbital maneuvers. I mean, I think I can't think of any, apart from, say, Deep Impact and L Cross. I can't think of many other times. There was, of course, or Rosetta and Philae, but I can't think of other times that.
There was Beagle, but these are all cases of spitting out a spacecraft.
Yeah, that's what I'm saying. I'm trying to think of examples where things docked in space, but really, it's all, the vast majority is them arriving at the International Space Station.
And so this was with the Soviet Salyuts. This was with the American Skylab. Then we had Mir, and The original Soviet idea of doing robotic docking has really been what's taken over since then, where we have Soyuz and Progress spacecraft automatically docked with Mir. The ISS has the Kurs docking system. Europe has the automated transfer vehicle. And so it's really robotic after robotic
Sorry,
after
Pamela, we
robotic
got to
system.
stop here. I'm getting a ton of dropped frames, so I don't know whether it's um, our fault or whether it's the router's fault. So I'm gonna restart my router.
Okay.
So
Do you want
don't
me to
go
pause?
anywhere, anybody.
Not touching anything then.
Yeah.
Sorry, Chad.
Okay. Let me see. I'm gonna stop my stream and restart my router. Let's see what happens.
Okay. I love that you Maresy dotes and dozy dotes and little amsy divey.
I just started the stream up again. We'll see what happens.
Okay, I'm watching to see if folks are seeing us on Slack or if we jumped to a new.
I don't think I don't. I feel like I've figured this out now. That if you, uh,
Susie says they see us.
yeah, if you click stop streaming within OBS, but you don't stop the stream in YouTube, that's the key. If you stop
Okay,
the
that's
stream
good to
over
know.
on the YouTube side, then it
Ends
whole
the
thing
universe.
jumps. Yeah.
Okay. Yay!
Yay.
Okay.
We'll give them a second to everything to settle down. Let's see if this works. I don't like if the problem is coming from YouTube, then I can't fix it by restarting my
Yeah.
router. But we'll see if restarting my router did the trick. All right. Do you remember where we were?
Yes, I was talking about robotic docking, and
Okay.
I thought you were about to correct me, but hey, I got lucky that time. Okay.
Please continue.
Okay. So now with the International Space Station, let me say that again. And now with the International Space Station, we're continuing this originally Soviet, then Russian and European tradition of robotic docking. We have NASA's berthing mechanism rather than a docking port, but mission after mission after mission, nation after nation after nation, this is the direction we're going. Japan joined in with their transfer vehicle, and all the spacecraft are all set up to essentially robotically go into station keeping, pull that Gemini maneuver of hovering without touching. I'm not touching you. Basically, this is what you want your children in the back seat to do. Stay equally distanced and not touch. And then the Canada arm reaches out and grabs the spacecraft. And so we've gone, and this just makes me giggle to no end. We have gone from robotic docking, meaning a fully automated get together and couple the spacecraft, to a automated hover, not touching, and then an arm reaches out and grabs that spacecraft.
Right.
It's lovely.
It really is the safest way to go about it. All right, so we've been talking about the docking maneuvers. Let's move on to the refueling side of things. So where is that happening right now?
Well, so this is where sometimes science fiction makes things seem easier than the paperwork actually allows it to be. We've tested the technologies for doing refueling in space, and this is one of those things that's really on the long-term roadmap as we look ahead to assuming the Space Launch System moves forward. Its first several launches are going to go towards getting us a little tiny spaceport out in cislunar space that nominally will be there for construction and refueling. And as we work on the roadmap to get towards that little space station, NASA has been testing the robotic refueling mission. It hung out on the International Space Station until 2017. Early 2017, it came back to Earth. It was considered a success. It showed that we have the ability to safely have a fuel depot in space. We have the ability to refuel things. We're just not going to keep doing it for the time being because the space was needed to test other things.
I mean, one of the things that's kind of interesting is with when the Soyuz and the Progress vehicles dock to the International Space Station, they don't transfer the fuel. They don't transfer their propellant out of those vehicles. They just boost the space station by using the thrusters on the vehicle itself.
Yes.
And so, when they're transferring additional, now I don't know if they transfer any propellant at all to the International Space Station, but all of the boosting maneuvers are done by these attached spacecraft. So orbital refueling is not something that's been done. But then, theoretically, it makes a lot of sense, right?
And it's with the robotic refueling mission, it wasn't so much that we were worried about refueling the International Space Station, because really you just attach a New Dragon or Soyuz capsule to it. The real question is, what do we do with all of the other satellites out there that we'd like to extend their lifetime? We've totally upgraded the Hubble Space Station, not Space Station. We've totally upgraded the Hubble Space Telescope, giving it the ability to stay out there a little bit longer. Now, imagine if we had the capacity to go out, grab Kepler, and refuel that little telescope. This would extend the science it would be able to do. It has always been in the roadmap to be able to go out and grab satellites, move them around, pick them up when they're broken, bring them home. I remember I was a nerdy child who went to space camp in the 80s, as one does. and hearing the stories of how they were planning to build these highly maneuverable satellites that would go around, grab satellites that needed to be fixed, pick up space junk. We're just not there yet. It hasn't risen to being a high enough priority. But we are on the pathway to test the technology, to show that it's safe, to do all of the pathfinding that's needed before we finally have that docking station out in cislunar space.
And you can imagine some of the more complicated missions that are going to be attempted in the future, especially things like sending humans to Mars, are going to require this refueling. And I think the sort of example that people are pretty familiar with is the idea that's coming from SpaceX for the BFR. The BFR is going to launch, and they've got the regular, the passenger version, and it's going to launch atop its first stage booster rocket and get into orbit. And then there's what they're calling the tanker, and it's going to be filled with methane. And then the two BFRs are gonna sort of dock end to end, and then the tanker is going to dump all its fuel into the spaceship, and now the spaceship is as fueled up as if it was still sitting on the launch pad down on Earth, but it's in orbit. It's already gotten out of that accursed gravity well from planet Earth, and now it can perform its maneuver and head off to Mars or other destinations. So that, right. I mean, that strategy makes a ton of sense. And you can imagine this future where there are these orbital fuel depots in various orbits. You talked about the Deep Space Gateway, something in low Earth orbit, something at Mars. And if you need to go anywhere, you stop at one of these depots and refuel.
And really, I just dream of the day that all these beautiful, completely functional spacecraft that we have in fairly low orbit or are doing highly maneuvering things are able to get refueled, and our Kepler spacecraft that is still functioning quite nicely can keep doing its job without fuel being a reason to stop.
Well, there's actually you may not be able to actually refuel them, but there are some spacecraft that are being developed that are kind of like parasites that clamp on to satellites that are out of fuel but are working perfectly well for all other purposes, and they will clamp on, and then they'll have a thruster and additional solar panels on them, and they'll be the ones who keep the spacecraft functioning. I think the greatest tragedy, and the one that people just can't stop raging about, is the fact that James Webb isn't going to have, there's no way to refuel it. There's no way to repair it. It's going to be the L2 Lagrange point. It's got 10 years of fuel, and then it's going to drift out of its position and be useless. It does have a docking ring on it, though. So who knows what'll happen 10 years from now. But
Yeah, can I just say I'm sad that the telescope won't live as long as it took to build.
yes, you could say that. But there's hope. There's hope. It's got, they do have a way for something else to attach to it and boost it. I wouldn't be surprised if somebody, if the BFR does only cost $7 million to launch, I wouldn't be surprised if someone, if Elon Musk with some pocket change sends off a reboost spacecraft to keep James Webb going for a few more decades.
Yeah. So we're currently in this meta situation as we record this episode where the US government has nominally completed writing a $1.3 trillion budget that will get us through to September. They're supposed to vote on it on Friday, which is before you hear this episode. And
let us know how it goes, how the vote turns out.
Yeah, we're currently waiting to see, does W first live or die? What is the line item for James Webb Space Telescope? All these things. It's Schrodinger's budget at this moment.
Right. All right, Pamela, thanks. I think I feel like we have wrapped up our series on getting to space and orbiting.
We have.
My heart hungers for some cosmology now. So we'll tack in a completely different direction. But it was a lot of fun. I hope we were able to kind of scratch everybody's space flight itch for a little while, and thanks for tagging along with us.
And I think it's time for an update on particle physics.
Whoa, okay, we're gonna go physics. Fine, no problem. I'm up for that.
It's all part of cosmology.
We'll see you next week.
Sounds great. Talk to you later. Okay.
Figure out exactly, roughly how late we were going to be there after I had to restart the router. I think we did okay.
Yeah. 85?
Yeah.
I just love the fact that they didn't do the orbital mechanics before they first tried to dock things.
I'm sure somebody was like, I don't think this works the way you think this works.
Yeah, right? and they were all like, no, nerd, go away. Because they're all test pilots. You can just see them making fun of the orbital mechanics nerd.
Yeah. And why isn't this working?
It's just, you silly test pilots.
Who had written PhD doctoral theses on orbital mechanics? So,
that was one of them, not all of them.
True.
And yeah, it was just.
That was awesome. Okay. So I can't stick around for too long because I got to prep for the Weekly Space Hangout. So we'll go.
I have to take a photo for you.
Yes, you do. So why don't we say you stick around for 6 minutes? We'll answer some questions for 6 minutes, and then we will shut this down. So
not all of them.
True. Oh, what the? Okay, I'm all right. I'll be okay.
Words, they're hard.
Go ahead, hit us with your questions. Particle physics. Was there something you were specifically thinking of?
There's just been a bunch of updates lately on potential found dark matter particles, new ideas for dark matter. The fact that we still have no idea what dark energy is.
That's your update? We still don't know what these things are?
Well, pentaquarks. We haven't really discussed pentaquarks. I want to essentially do a roundup of the last round of what was and wasn't found by the Large Hadron Collider, what this means for current theories, and the fact that dark matter is stuff. Stop saying you don't know what it is. We know it's stuff.
Oh yeah, what kind of stuff?
Non-baryonic stuff.
Yeah, that is not specific enough.
So we have
But
much more specific information.
But it's not, we don't know what gravity, we don't understand how gravity works.
Exactly.
Yeah.
Exactly.
Yeah. Sure. That sounds good.
Okay. And we're not discussing string theory.
You know, string theorists don't discuss string theory anymore.
The conference I was at in Israel had 2 string theorists.
Yeah.
They discussed string theory.
Together with each other.
And they argued violently.
Did they?
Well, there was no violence. They were quite polite, but they were quite impassioned. So let me put it that way. They argued impassionately.
Yeah. But the fact being that the number of people who really believe in string theory now, or do a lot of work, I mean, they've all evolved, right? They've all moved along into other things now. So
yes.
May Vision. What is the Black Knight satellite, and why do people think it's over 13,000 years old?
What?
Yeah, exactly. Don't worry about it. It's an internet conspiracy theory.
Okay.
About some secret satellite. So, the people are conspiracy theorists, and they are using, in some cases, they appear to be just kind of making stuff up. And in other cases, they're just they're using it as a placeholder for all kinds of UFO kinds of things. So,
they've just been reading too much Arthur C. Clarke.
Or not enough.
True.
Yeah.
True. Kim Stanley Robinson has a new book out that I'm going to read on this trip because I have a lot of airplane time. Where there's a monolith found on Pluto.
Yeah.
You're not excited about this book. I am excited about this book.
I mean, is it is it in the same universe then as
I don't know. I haven't read it yet.
Okay.
Oh, no. I bet it's in the same universe as a lot of his other books. Kim Stanley Robinson's pretty good about not multiplying his number of universes too much.
Yeah.
I'm looking up the name of the book now.
Ben Appleby wants to know, would a nuclear pulse propulsion spacecraft be useful for placing orbit safely on an SLS or a BFR? Like an Orion, Project Orion, dropping nuclear bombs out the back and using that to thrust.
I'd rather not do that.
Yeah. Yeah.
It just seems like a bad idea.
Yeah.
Kim Stanley Robinson's new book is called Icehenge. It's on the North Pole of Pluto. There stands an enigma, a huge circle of standing blocks of ice built on the pattern of Earth's Stonehenge. And that's as far as I read, and I bought the book. Yes.
Whoa. Okay. Kim Stanley Robinson is a crowd pleaser. You can't go wrong with his books.
No. Yes, Michael Mayer, Kim Stanley Robinson gets his physics correct. And Kim Stanley Robinson is actually responsible for me totally misgendering someone who was then very confused at why on earth I would think that Kim was a boy's name. I was writing emails back and forth, and I referred to someone as a him whose first name was Kim, because Kim Stanley Robinson. And I went to a high school with a kid named Kim who was Swiss and was a he. And apparently most people named Kim are women, and if you misgender them because you think Kim is a boy's name, they are confused. They are confused. Okay, I'm babbling. I'm going to shut up and drink coffee.
You're not a crazy person. Let's see. So Arjun wants to know, could you have a water planet without a substantial atmosphere?
Yes.
If it's frozen, a frozen water planet. But what if it's a liquid water planet? Does it need to have it needs to have some kind of atmosphere, because it's going to...
It doesn't have to have substantial if it has enough gravity. So if you have it under enough pressure, I think you can pull it off. I think there's like a very fine balancing point you'd be at. So you'd have to have the temperature and the pressure just right to pull it off. But I think you could pull it off. You'd need some atmosphere, and it would be a transitionary water, because it would be evaporating over time. But yes.
Right. But
You
like
could
if you
have
have
a temporary, not a lot of atmosphere water world if you had enough gravity and the right temperature.
now temporary is the point because
Yeah,
if it's
it is going to
liquid,
sublimate.
it's going to be sublimating. It's
Yeah.
going to be getting blasted by. I guess it would have had a really powerful magnetosphere. So the solar wind wasn't going to be impacting it.
Then it would create an atmosphere.
Then it would create an atmosphere.
Yeah.
Right. It would hang on to that atmosphere, and then that
Yeah.
atmosphere would block. So I guess that comes back around and says, no, you couldn't have a water world without an atmosphere.
You could temporarily, just like Mars temporarily had oceans.
Right. Right. Temporarily.
Yeah.
So you could be in a transition
Yes.
to its total destruction.
Yes.
Ben Appleby asks, will the Russians stop using the Soyuz if the Dragon 2 is considerably cheaper? Ooh, that's a good question. What do you think about that?
Say that again.
So will the Soyuz, if the Dragon 2 is considerably cheaper than the Soyuz, will the Russians stop using the Soyuz?
I think it is politically unastute for me to answer that
Sure.
question.
Allow me to answer it. I think that there's no way the Russians would stop using the Soyuz for the Russian cosmonauts. And I think that there's no way that the Americans would keep using the Soyuz if the Dragon 2 comes online and it's human rated. And so I think what you're going to see is the Russians launching their cosmonauts to the ISS and other, maybe sometimes Europeans, maybe the Japanese, and I think you're going to see the Americans going up on Dragon 2s, and then you're going to see them having sometimes Europeans, right? So I think both spacecraft are going to go. The Russians will all take Soyuz, and the Americans will all take Dragons, and then everybody else, who knows what they take. That's what I think is going to happen.
What I'm really interested to see is if we ever get past this whole we allow Russians to have our technology but the Chinese can't, which currently has me deeply confused. I'm just going to lay that out there. That one has me deeply confused. The fact that Chinese aren't allowed on the space station and the Russians aren't an issue when we fly on their spacecraft. So at the International Space University several summers ago, I heard one of the high ups in the Chinese space agency talking about how Elon Musk's costs make it such that even China, with its incredibly cheap labor and cheap steel, isn't competitive in the costs of rockets. And if we didn't today, but if we didn't have ITAR regulations, would the Chinese be using SpaceX?
That's a good question. So did the ITAR regulations force the Chinese to develop as
totally
capable a space exploration, launch capability that they did? I mean, they're working on we're doing some reporting on this right now at Universe Today. They're working on a rocket that's going to be as powerful as the Saturn V. They're working on full reusability. They are filling every single niche. They're catching up in terms of total launches to the Americans. I think that we're going to see a serious competition coming out of China to SpaceX in the near term. Within the next decade or so, we're going to see a it's going to be a two-horse race. It's going to be SpaceX and the Chinese, I think. I'm still sort of forming my thoughts on this as I see this all unfold. Anyway,
I'm just not sure.
Let's wrap things up, but keep those questions and ideas in your mind, because the weekly Space Hangout is going to be going online in about 40 minutes, and I'm sure Nancy will tell us who our cool guest is.
Oh, you have Marion Call on tonight.
Oh, do we? Oh, that's going to be weird. I'm trying to think of how we're going to do this. All right, that'll be fun.
She's awesome, so enjoy that.
Of course. She was with us at the eclipse.
Yeah.
All right. Well, thanks, everyone. Thanks, Pamela. Thanks, as always, to the WSH crew. They provide the chat. They are the heart and soul of everything we do. So go to wshcrew.space and join them. All right. We'll see you in 40 minutes.
Have a great night, everyone.